Hello everyone, my name is Peng and from Meta, currently working on the Messenger Android app.
My name is Sergei. I'm also working at Meta on almost everything that is related to Kotlin.
Okay, today we are talking about Kotlin first at Meta. So, how many people read this news in the Hacker News? Okay.
Oh, there are some.
There are some, that's good.
That's nice, that's
so,
nice.
For those who haven't read this one, we have some exciting news to share. Since we started to adapt Kotlin 4 years ago, we have reached 10 million Kotlin lines on our Android code base. So now we have tens of thousands Kotlin modules, and thousands of developers are using Kotlin every day. So in this talk, we want to share some lessons we learned from how we shift from Android developer from Java to Kotlin. So we have a previous episode which we talk about in the New York Times, which we talk about how we do the adaptation and all our main blockers. In this talk, we will talk more about how we speed up the adaptation since our last update. Let's start by talking about what Kotlin first means here. So it will be the default language for all our Android code base. So it means all the new code will be Kotlin, apart from some exceptions. And it will also start to auto-convert the Java language to Kotlin. So that means our Kotlin coverage will increase continuously. Of course, we want to put our developer happiness as our top priority when you start to write, build, review, or ship code. So let's dive into our current workflow. This is the area we want to cover today. Shape code is our first blocker we have addressed in our previous talk, so we will not give more details in this one. Everything starts with writing code, right? So always start from there. How do we write code? First, you need IDE. We are using Android Studio, but with a lot of customization. I will talk why later. Then we have code mode. What code mode means here? We don't want manually to change or refactor a lot of code base because we have a huge code base. And therefore, we are improve our code mode for Kotlin, so the code can write itself. We are also migrate our framework to Kotlin. It includes UI, dependence, plugins, and all the tests. With our test, for the same screen, with Kotlin support, the line could decrease 30% or more. We also enable the progress mode for our Kotlin building pipeline. So it helps us to catch bugs earlier and upgrade Kotlin quicker. So what's the issue we are facing for the IDE? Because we have a huge code base and all the Android codes in the same repo. It has more than 100,000 modules. Android Studio can only support around 1,000 Java module folks. But for Kotlin, it only supports a few hundred. What happens if we're loading more? It will cause Android Studio to freezing. How can we improve that one? First, normally, we will focus the plugin and do our own iteration within Meta. So we do a lot of profiling analysis where the issue is. Then we also collect feedback from the developers so we can pinpoint the area they care most. But there's an issue here. Every time we do some improvement, the developer need to go to upgrade their Android Studio. And it's really tricky for developer to upgrade. So the feedback loop will be really long. Remote development. Will that handle that everything? We see the JetBrains have projector and the remote development project already there. But the user experience is not as good as we expect, so it still has a long way to go. we talk about IDE, and then we start thinking about the code mode. Code mode is we are thinking, how can we change the code more easily since we have a huge code base? And how can we do the work as simple as we can? So we provide the framework so the developer can easily to refactor involve the typing, nearability, or inheritance. Or we have some linter to check in. If there's a local static access, we find the issue, you can easily to fix by our code mode automatically. You also notice for some Android linters, they have auto correction features. So we can apply the auto correction feature directly from the linter. So you don't need to do it by yourself. We will do it for you automatically. Let's go through the pipeline we have for the code mode. First, we need to scan the whole code base based on the feature required. For example, you want to have some analytics based on some code features. Or we can use in the AST, abstract syntax tree, to find where the type you want to change. Once we identify the code change, then we start to do the refactoring. You can change the class name, method, or content, everything you think will be easier for your code, right? And we can apply the auto correction immediately, directly, without user change. After all this one, we will start to run another analytics and test to make sure the change will not break anything. Once all the tests pass, we will publish the change and let the developer to review it again. The code mode can save days or weeks time because if a framework applied by 1,000 or 10,000 modules, if you manually to change that, you will take months to change it. But once you have the code mode, you probably need to write the code mode in 1 or 2 days, then apply it automatically. Because the code mode, you write in code, so you can refactor or use it in the future. Or even more, you can run it continuously. I will talk more why it's important later. So we talk about how we write Kotlin. Then let's talk about how we want to convert Java to Kotlin. Within Android Studio, you have the convert tools easily, Java to Kotlin, but we cannot use it. The main reason is we have a lot of framework and plugins which are specific for the meta, and we need to upgrade the plugin to accommodate to the Kotlin modules. And also the tools need to handle a variety of framework specific for meta, so it's a lot of work. Since we have all the tools here, developer can easily to convert from Java to Kotlin. The main concern is how do we handle the nullability and type system? Because, for example, we don't know if it's optional or not optional, right, when you change it. But when we have the annotation, it makes the change much easier. Let's see the pipeline here. For one Java module, we have prepare, convert, and post-process for the Kotlin. Since we have all these tools ready, we are thinking, why not make it automatically? So we're building this pipeline to automatically convert Java to Kotlin. Here's what we have to do. When in the prepare state, we have the internal tools transfer, which I mentioned before. It will transfer all the modules which are required for the Kotlin-specific plugins. Then we will call the headless Android Studio to call the Java to Kotlin tools to convert the Java file and the modules to Kotlin. After that, we will apply all the linter or Android Studio auto-corrections tools to optimize the code. You will feel this is really similar to the code mode, right? Because the post-process is running in the code mode. That's why everything you read before could be applied for the future. Recently, we also open source our Kotlin AST tools. So that means you may not use this tool directly because it links with our pipeline really tightly, but you can get some ideas how we can apply or change for the big bunch of the Kotlin files and optimize for the Java conversion. So we talk about the Kotlin, how we think will be working now. But let's talk about Kotlin as a new language. Kotlin has improved a lot since the early stage and fixed critical bugs quickly. But one interesting part is it will only release for this bug in the major version upgrade. So it will not disturb the developers. So how can we use the feature or check from the future version, right? How many of you using the Kotlin 1.7 now? Not many, right? So we are also not in the 1.7 yet, but we want to use some feature from 1.7. How can we do that? Progress mode coming to help. It is introduced from Kotlin 1.3. First, it will improve the feedback loop. Instead, fix the bug when you upgrade in the major version. When the mode is enabled, you can fix it in your daily job. Another thing we can do is, since we fix all the bugs in the daily job, so when you upgrade to the new version, you don't need to have a big refactor or big change, so it makes the upgrade much easier. When we enable the when we enable the progress mode, we find some interesting example I want to share with you. This is first one. So, for example, we have a cell class with color red, green, yellow, right? So you have a function to using this color. Then you enter blue. What do? You may now say, oh, I don't need to handle blue. There's no error here. But if you see carefully, the Android lint will give you a warning to say, and it's blue or else branch instead. But think about it, your code is using by 100 or 1,000 modules. It's really tricky to find all of these warnings by hand, right? Interesting one, this issue is already handled in the 1.6, but it's not enabled. You will see this error in the 1.7. How can we do that one? Once we enable progress mode, you will see the error directly to tell you when it's not handled correctly. There's a blue into do it. So that means it can find the bug easily, and the feature check could be applied even in the 1.6. Now we know the progress mode is effective finding issue from the future error check. Here I want to share another example, how it can help us for the Java and Kotlin interaction. Because most of our code is still in Java, and there's a lot of interaction between Kotlin and Java. From Java 8, we have the generic not none annotation. So it helps us to make the non-check much easier in Java. But it doesn't working well with the Kotlin generic parameters because the upper bound restriction is not applied. It's kind of not easy to understand. I give you another example here. So on the left, we have Java files, right? We have example, we have put, then we want to make sure the element in is not null. And then we have interface. This is interface in Java. Then we have the Kotlin file to implement that one. It all looks good, right? But it's not. You will see the user code failed with runtime exception because the E here is not applied as any, it's RNA optional. So that means you can easily to put none in the code and it's still compared, and it will get a crash. So that means the type safety guarantee is not met here. Interesting one also, the Android Studio, the lint will tell you something wrong here, but probably you already ignore that one because once you update, this thing you may not see it directly. But once you enable the progress mode, this will be happen. It will show you an error. Put override nothing. Why is override nothing? Because it applies restriction. You need to extend E not any optional. You will extend E as any. That makes sure it will be not nullable. So we can see with optional, with progress mode enabled, it helps us to find the bug which we didn't see before. And it will be also help us to make sure the check from the future work. Okay, now we have read some code. We need to review it. I want to give you a really quick crash course for our review process. So what we have put to make the review process much easier for the Kotlin code. First, we are using our own formatter. It's consistent and it's open source already now. The output is deterministic and is independent of the input code. So it means everything you put in, we will get the correct, always get the same result coming back. Then we apply a lot of linter check for our Kotlin code. It's from either from default Android linter or from our internal linters. So we also have tools to help us to apply or end the linter much easier for the Kotlin code. Then we have a lot of static analysis. Two things I want to point out we find is really useful is thread safety and IPC on UI thread. So that means make our code much safer when you're using Kotlin, especially when you want to use coroutine or this one. There are few linters we have, and I want to point out this is the one we find really useful. Maybe you can have to do your own things. It's code styles. Because every time every people have different opinions for the code. If you want to make sure everyone to make the code review quickly, a code style is really important here. Then performance. We have a lot of API, and some performance is better, some performance is bad. So we want to make sure you are using the correct API to get the correct performance. Safety. We have a lot of security issue regarding how the code you are using, not to expose other code to the other applications. So that's the safety is applied. Risk condition. Especially we are start to adapt the coroutine. We have few issues with racing to the risk condition areas. That's why we put more effort for the risk condition. Of course, we want people to using Kotlin first framework. So that's why once you're using some work which is not Kotlin first, we will give user to say, look, you should use Kotlin first, right? And this is how it will look when the error is happening. We will tell you exactly what's going on and how you can fix that easily. Okay, I will pass it to Sergei to talk about the build.
All right, you thought I'm just standing here? Not really. I'll tell you a bit more about our builds. Thanks a lot, Peng. And yeah, we talked a lot, or at least some, about our code conversion to Kotlin. And you know what? At the end of the day, we'll have to build all this code. And in this audience, who is happy with the Kotlin compiler throughput and the build times? Anyone? Any JetBrains guys here? We see you. Please improve it for us. OK, I have a very aggressive adoption, Kotlin adoption receipt for everyone here. Let's do something like this. Aggressively convert things to Kotlin, then degrade build time, then degrade clean build time, incremental build time, and finally suffer from extremely slow builds. And this is something that's going on here and there across the industry. And it's quite bad, and mainly because we utilize a lot of CI, we utilize a lot of developers' time. There are also companies who are trying to build their products on the slow builds, probably even some of them at this conference, but whatever. It's great we have these companies, but it means that builds are not that great. Let's get into several build categories to understand what's really important when we build something. First of all, the clean build. What it is, it means that you've just checked out something, you don't have any cache, you don't use, let's say, network cache or anything preheated for you, you just build. What is important in this case? Like almost everything. Let's just change the granularity, a single target build. Imagine you just change something in one of your modules, let's say a public method or something inside. Your dependencies, they just didn't change. What changed is this concrete module. So what is important for you is how fast is Kotlin compiler itself, or Kotlin compiler with Java compiler during this build. So it usually named in compiler theory a compiler throughput. And we care about compiler throughput optimizations. Then let's imagine you're developing a feature. You change some API here and there, probably 10 modules affected. Whenever you try to compile this, it's an incremental compilation or an incremental build. And for this incremental build, what is really important is a build graph optimization. So there is such a thing called the critical path in each graph, and you cannot get faster than the compilation of the critical path in your graph. There are various ways to optimize each of these build types. But since we do incremental builds more often, let's first get into the incremental build analysis. There are different ways to compile things incrementally, and different build systems handle it differently. But what is interesting for us today is the thing called application binary interface. This is like an API of your jar. Everything not non-private that you expose as a part of your build. Why it's faster to compile against ABIs? First of all, they're just smaller. You can transfer them faster through the network. But then, if you use a certain cache hit strategy, at the end of the day, what you do when you build, you compare something with your cache. And if it hits, then you just take things from your cache. It's possible to compare different things while you're building. In most of the cases, it's called the rule key of your build. Rule key contains some parameters. For example, whatever you pass to the Kotlin C command, or Java C command, or Gradle command, depends on the build system. But let's get into the details what is ABI compared to a simple Java example. Let's say we have a class foo with some private final members. We have a few functions here, getter, and the constructor. Let's try to do a naive stripping and remove everything private from this. Implementation and private members. And finally, we edit it as a raw file, so it means we just strip text from this file. What we'll get is a couple of methods, a class declaration, probably constructor. There are a few ways to build your application against ABIs. We'll try to discover some of them. When we operate with Bug, the default build system at Meta, we define three different modes: class, source, and source-only ABI compilation. The simplest one is a class. It means that you need to build everything, build all dependencies, then you get to your target. You compile a target, and then strip everything private from this target. And the result will be an ABI jar. We are using this naive stripping as I showed you on the previous slides. Source ABI is slightly more complicated. Compiler is an interesting creature. It has a few stages there. It has the compiler frontend and the compiler backend. And to generate ABI, it's not always necessary to invoke the compiler backend. So in some cases, it's possible to build everything earlier if some conditions are met. And source-only ABI is something very different and probably magical. Instead of building your dependencies, you're guessing them. We'll get to it in a while. And then you're also running a compiler frontend. But yeah, we are adopting Kotlin, but previously we had Java and probably 5 to 7 years of Java optimization. Let's first try to understand how the Kotlin ABI is different from the Java ABI. So one of the first example is the optional or nullable, non-nullable types. In this case, it's either bar, with a question mark or just bar. So what we'll get as a result in the ABI, and what are the differences? So there are a few of them, and unsurprisingly, Kotlin type system is somewhere hidden inside these three things in the bytecode. First of all, it's a nullable annotation for nullable types, and the other piece is the Kotlin metadata that contains a few things that allows Kotlin to unpack its build system things using the same bytecode as Java does. So you see there are some changes, but none of them are in the method declaration itself to make it compatible with Java. Another part is the changes in inline functions and how they are represented in the bytecode and ABI. As inline function could be inline, obviously, you have to put everything from inline function in your ABI just to be portable to anything else that, anywhere else that depends on your ABI. And it's a big thing. And finally, the way how the private members are handled in the ABI. So if you try to compile a class C with the foo and the bar, which are private and should not be a part of the ABI because they are private, this is what we are getting. We still get a bar and the foo as a part of the Kotlin metadata annotation. And this is interesting. So naive stripping doesn't work with Kotlin because you will still have private details in your ABI. That just doesn't make sense. And thus we need the non-naive stripping. That is based on the analysis on the class visitors. So for example, there is an ABI class builder thing that can either visit your new methods, new fields, or class definition, where you can check if it's private, if it's something that you need to inline at the end of the day, or even if you need to define a class. Let's get into more build details. We are building an app that depends on the bar, that depends on the foo, that depends on some util and constants. So a few packages. Let's now try to apply the class ABI building strategy. So to build everything with a class ABI, we'll need a few intermediate steps. For utility ABI, for foo ABI, and somewhere else for const ABI. But these ABI stages are much more lightweight, so you can hit the cache hit much, or the cache fetch much earlier, so you need to rebuild less things than usually. And yeah, reminding ourselves what is the Kotlin compilation. Kotlin compiler has obviously a front end and a back end, and somewhere it also has a middle end, which we are not discussing today. But it has to parse a syntax tree and figure out the signatures of the methods, constructors, everything else. And everything that we really interested in is in the compiler front end to generate an ABI. So we can generate it after the front end. It means, what if instead of running just one process that goes the whole pipeline to the full ABI and then strips everything, we run two instances, probably one of them remotely, that will generate an ABI jar and full jar for us. As a result, we can significantly change the build graph by starting these two processes separately. So this graph, even for the small app, is one layer less than the previous one. Then, source-only mode. Let's try to imagine what if we would be able to start generating the ABIs for both util, foo, and const ABI from the very first moment when we are starting the build. It seems wrong because we don't have dependencies, obviously. But let's look into some interesting things. Imagine you have the class C, a function foo, there that just return a user that it instantiates. And this user is imported from the external package. What is user from this? The perspective of reading this class C file. User is something that you can invoke constructor on. That means it has these braces and it has the constructor call, and you can see this constructor call whenever you observe the AST or PSI from this file. That means that the only thing we need from user is to have its constructor to compile this file. And we only got it from analyzing this as a text. So you do not need the dependency of this file to actually compile it. Another dependency guessing example is the import in this class. So let's think that we have an import of an important string that is used in the annotation. What we can say by this import, it has uppercase that looks like a constant in both Java and Kotlin. Probably it's a constant. But again, to keep it a constant, we need a clear style guide and placed everywhere in our code base. But probably we can guess that it's a constant and create it somewhere that is equal to, well, like whatever. But we'll be wrong in this case. So for example, in this assignment in foo, we assign this important string to an int, which is incorrect from the language perspective. So we can make another guess. Then instead of int, for some reason this important string, instead of string, this important string is actually an integer. And we might be correct because it's legal to pass an integer to a value of an annotation because integers are available in the compilation time, so it's going to be fine. And there are really a lot of traps in this guessing, but if you apply a correct set of invariants and if you keep these invariants in your code base over time, you can definitely flatten your build graph significantly. There will be another episode of the talk that is mainly focused on the ABI this November in Amsterdam on the Kotlin Dev Days. If you're joining, don't be a stranger there. The last thing I wanted to mention is the single target optimizations. Single targets are really important when your change is localized, but they're also important when you build a clean thing. And we have a few suggestions here of how to make the single target compilation better. First of all, it's the new Kotlin compiler K2. If you didn't try, probably you should. You'll suffer for a bit, but at the end of the day, it will work for you. Another thing is the KAPT deprecation. We strongly believe that no one should use KAPT these days, and we should define the clear strategy of how we are moving to KSP, Kotlin simple processor. And if you have really massive builds, it's probably good to use one of the new preview features from Kotlin called the backend parallel compilation. It might be promising, but it didn't work for us, unfortunately. We got the regression when we tried to enable Kotlin parallel compilation on the backend. All right, takeaways. Use Kotlin by default. It's 2022 finally, and it's a bit awkward for me to say it this year. Probably we should have sent this message a few years ago. Utilize compiler features to get feedback to users as early as it's possible in your development cycle. And use the incremental features and the compilation against ABI in your build system. Fortunately, these days, many build systems provide these abilities. And thanks a lot for being here with us. I hope you had a great conference. Thank you.